Hello everyone, I'm James, a long-term statistics student who will be bringing you all some introductory level statistics explanations. To visualize everything though, I'll be reviewing the Art of Stat Distributions app, and the app can do many things, but what I'll start with is the normal distribution. To get your hands on the app, you're going to go here, we're on the front page of my phone, you're going to go to the App Store, you're going to type in Art of Stat at the top, and it should be, just like this, Art of Stat. It should be the first result for you. If it's not, it'll be among the first three, but that's how you're going to get your hands on the app, and once you've downloaded it, you can see it right here. We're going to open it up and go to the blue distribution here, the one that says normal, because this is the normal distribution. And this normal distribution is most commonly considered bell-shaped, and it's defined by two important parameters, mu and sigma. Those parameters, mu and sigma, stand for two different things. So mu describes the mean, and sigma describes the variability of the distribution. Let's kind of see what happens when we change the numbers here. So we can change the mean, and let's change that to 100, and we can change the standard deviation, we can change that to 10. And let's put a real-world example behind it. Let's say that our distribution is the price of tickets to fly from New York to Washington. So they have an average of 100 with a standard deviation of 10. So when we press the button here, we can see definitely how the numbers change on the graph in front of us, but they aren't as easy to understand how the parameters are impacting the actual graph until we press the Explore Meaning of Mu and Sigma button. So let's move around the mean up and down, and you can see that the whole graph shifts alongside the mean because the graph is centered around the mean, which is mu, and then the standard deviation makes not as direct sense. As we increase the standard deviation, it becomes shorter and wider, and as we decrease the standard deviation, we can see that the values become more compact and narrow. Sigma allows for more or less variability. So if you take the slider for sigma and make it smaller, that makes the prices more peak. So more often people are paying $100 or closer to that as their price for the ticket. Something important to note as well is that it may start to look a little bit weird, especially as you start messing around here with the standard deviation. And even if we mixed up both, it might not look as perfectly bell-shaped as we had originally seen, but something that to keep in mind is that it's still symmetrical, and that's also pretty key in defining the normal distribution. A really cool feature that's true for any normal distribution you look at is called the empirical rule. So let's go back to the main page here, and the empirical rule tells us that 68% of the values are within one standard deviation of the mean, 95% of the values are within 2 standard deviations of the mean, and 99.7% of values are within 3. So what this means is if our standard deviation is 10, one standard deviation above the mean is 110, and one standard deviation below the mean is 90. If I could draw like an imaginary line up from 90 and up from 110, that would be one standard deviation from the mean on both ends, meaning that 68% of all the values would be within those. Let's bring this back into the context of the question. If we drew a line up from 80 and 120, we would know that about 95% of people paid for flight tickets that priced somewhere between $80 and $110. At the very bottom of the page here, if we scroll down, are some very common percentiles of the normal distribution. And if you understand that already, this will be really helpful to you, but we'll actually talk more about that in video 3 of this series. You might be more familiar with percentiles from results on standardized testing. I'll further be exploring the Art of Stat Distributions app and specifically the normal distribution in about 2 more videos. I hope that it's been helpful so far for understanding the normal distribution, at least on a surface level. I'll see you soon.